Welcome back to the SDL2 plus OpenGL shader mini-series. So in this log, we'll bring our triangle to life using uniforms to create a smooth animated color effect. You'll learn how to pass real-time data from C into your GLSL shaders and use it to animate color directly on the GPU. It's your first step toward interactive and dynamic shader programming. So by the end of this log, you'll fully understand how uniforms work in GLSL. By the end of this log, you'll fully understand how uniforms work in GLSL and how to make your graphics react in real time. Now for the project structure, we have the samemake_list.txt, main.c, and a shaders folder. Inside the shaders folder, we have the vertex and fragment shader.glsl. Now we're going to have the samemake_list.txt. So we're going to configure our samemake. So samemake responsible for creating the executable file and linking the libraries that we needed. Now for the vertex_shader.glsl, so we will going to have the vertex position and the vertex color. Now for the output, we will going to have the fragment shader, or we will going. So for the output, we will going to have a vertex color. So we're going to pass this to the fragment shader. So inside the main function, we will going to set the final clip space position via gl_position, and then we will going to send the color to the fragment shader via the output vertex color. Now for the fragment_shader.glsl, so we're going to have a vertex color, and then the output is the prog color. And then we will going to have a uniform float U time. So this is time value from the CPU. And then inside the main function, we will going to oscillate between 0 and 1, and then modulate the color with the time. And then we will going to pass the final color to the frag color or the fragment color. Now inside the main.c file, we're going to initialize the SDL2 windows with the OpenGL context, then load and compiles two shaders written in GLSL, and then we're going to upload the triangle vertex data to this GPU and use the shader to draw the triangle on the screen. Also, we include the libraries that we needed. So here we are the SDL2 or the SDL.h provides the functions for creating a window, handling input, and managing other graphics contexts. GL or glue.h, this is the glue or the OpenGL extension wrangler, a library that helps manage OpenGL extension and the function pointers. So stdio.h is a standard input or output for printing messages to the console, which is the printf and fprintf. And stdbool.h provides the bool type for boolean values like true or false. And then stdlive.h provides the utility functions for memory allocation, processes control, and other things. So math.h is standard math function like sin and cos and other math function. So here we have a constant, so we define a constant for the window width and height to be used later when creating the window. So we have the function prototype. These are the function prototypes. So it appears the function that will be defined later in the code. So specifying their names, return types, and arguments. So here we have our main function. So we have the entry point of the program. argc and argb are the command line argument, but they are not used in this case. So for completeness, we just added it. Now for the window and context initialization, we declare a pointer for the SDL window, and then a OpenGL context, which is the GL context, and a Boolean flag running to control the main loop. So we're going to call init underscore SDL OpenGL function to initialize the SDL and OpenGL. If the initialization fails, it prints the error and exit. Now here, the creation of the shaders. We're going to load and compile the shaders, which are the vertex and fragment underscore shader.glsl using the create underscore shader underscore program function. If the shader program is created successfully, it prints a success message. So for triangle vertex data, we define the triangle vertices is each vertex has 3 values for position X, Y, and Z, followed by 3 values for color RGB. Each vertex has 6 float values. So for the OpenGL buffer creation, we generate a vertex array object and a vertex buffer object. The vertex array object holds the state related to the vertex data, while the vertex buffer object holds the vertex data itself. Now we're going to bind the vertex array object and the vertex buffer object. This uploads the vertex data, which is the vertices, to the GPU with the GL buffer data. Now setting of vertex attributes, we will going to define how the vertex data is interpreted in the shaders. So the first attribute is the position, which is 3 floats, and the second is the color, also 3 floats. And GL vertex attribute pointer function tells OpenGL how to interpret the data for each attribute. And GL enables vertex attribute array function enables the attributes to be used. Now we're going to have our timing set up. So here we have set up the timing. So SDL get performance counter function returns a high resolution performance counter. So and also SDL underscore get performance frequency function gives the number of the counter ticks per second. So for the main loop, we have the process underscore input function. It will going to check for the input process or such as closing the window or pressing the ESC key. Then we have the time value. It will going to calculate how much time has passed since the program started in seconds. So we have also a render function equal to render the scenes, and SDL underscore GL underscore swap window. So it will going to swap the OpenGL buffer showing the rendered frame. And then we're going to clean up all the OpenGL and SDL resources, and it will going to delete the shaders, buffers, and also the OpenGL context, and lastly the SDL window, and quits the SDL. So here we have our function definition. So first we are going to have the init underscore SDL underscore OpenGL. So it will going to initialize the SDL and OpenGL context. And also it will going to check for errors and return false if initialization fails. And then we're going to request the OpenGL 3.3 core profile and also set the OpenGL version to 3.3 core. And then we're going to have the window creation. Next, we're going to have the OpenGL context creation as well. Also, we're going to initialize the glue. Now we're going to print out the OpenGL version and set the OpenGL viewport, set the default color to black, and then enable the vsync. Now we have the read shader source function. So we're going to have a shader loader function. So this function is going to load the file or the vertex and the fragment shaders. So now we're going to have the compiler and the linker for our shader. So we have a function called create shader program function. Now here I will going to read the vertex and fragment shader.glsl. Now we're going to create the vertex shader, and then we will going to print an error message if the creation is not successful. If successful, it will going to print out okay vertex shader. Now we're going to create a fragment shader. So same thing in the vertex shader, we will going to print out an error message, and if successful, we're going to print out an okay fragment shader. Now we're going to create a linker, or the compiler and the linker. We will going to attach the shaders, and the shaders that we wanted to attach to our program are the vertex shader and the fragment shader. And then we will going to link that. And then if the linking of the shaders is got an error or it's not successful, we will going to print out an error message, and we will going to print out, if successful, we're going to print out a message as well, like okay shader linked. Now we're going to clear up the resources that we used, which are the vertex shader and the fragment shader, and we free the v source, or the vertex source, and the fragment source, or the f source. And then we're going to return the program if it's successful, or if the program is successfully created. So we're going to return that. Now we have a process underscore input function. So this function handles user input like close window, ESC or escape key. It sets the running to false to exit the main loop if the window is closed, or if the escape key is pressed. Lastly, we're going to have a render function. So it will going to clear the screen, use the shader program, pass the time value uniform to the fragment shader, and then binds the vertex array object and draws the triangle using the GLDrawArrays function. And that's it for this log. You'll just build your first animated shader using a uniform variable to pass time and smoothly pulse your triangle's color. This same technique is used in advanced effects like lightning, reflections, and motion-based animation. So this is a big step in mastering GPU programming. So in the next log, we'll dive into one of the most powerful concepts in graphics, which is the model, view, and projection matrices. You'll learn how to move, rotate, and scale your object in 2D and 3D space. If you enjoyed this log, give it a like and subscribe. Thanks for watching, and see you in the next one.